many dipoles form as the action potential is spreading throughout the heart. In the previous video number 4 of electrocardiography, I took only one of these dipoles. In other words, I had a constant dipole. And then I placed many positive electrodes around that dipole at many different degrees. And I examined how this dipole is reflected as electrocardiography waves onto these electrodes. For all of the electrodes, the dipole was the same. However, it was reflected as electrocardiography waves with different shapes and different sizes to each of these electrodes. In this video and in the video after this, I am going to examine all of the dipoles that are formed during the depolarization and repolarization phases of action potential as the action potential spreads throughout the heart. So, in other words, the dipole is not going to be constant. On the other hand, my electrode is going to be constant. I will have only one electrode. For this video, I have chosen the D2 electrode, which is at plus 60 degrees. In this video, I am going to examine how depolarization phases of the action potentials are reflected as electrocardiography waves. In the next video, I am going to discuss how the dipoles during repolarization phases of the action potentials are reflected as electrocardiography waves. Before starting, I must talk about 3 important points. The first point is that electrocardiography reflects the depolarization and repolarization phases of the action potentials that are formed only and only in the atrial and ventricular muscle cells. The 12-lead electrocardiography that we use routinely places the electrodes on the surface of the body. The electrodes are in contact with our skin, and a surface electrocardiography like this is able to record the depolarizations and repolarizations of the action potentials that are only formed at the atrial and ventricular muscle cells. If we want to record the electrical activity of the conducting system, the nodes or the Purkinje cells, we need to be closer to these structures. For this purpose, intracardiac electrodes can be used. The second important point is that the shapes of the action potentials that are recorded from atrial and ventricular muscle cells are pretty different from the electrocardiography waves that are recorded from these same structures. Here you can see one action potential that's recorded from the atrial muscle cell, and then one action potential that is recorded from a ventricular muscle cell. These are intracellular recordings, and they are recorded from only one atrial muscle cell or one ventricular muscle cell. In intracellular recordings, one of our electrodes is in the cell and the other one is outside the cell, and we record the electrical potential difference between the two sides of the cell membrane. Electrocardiography, on the other hand, is an extracellular recording. Both of our electrodes are outside the cells, and we are recording from all of the atrial muscle cells or all of the ventricular muscle cells. This is why the shapes of the action potentials and the electrocardiography waves are pretty different from each other. If we look at the electrocardiography waves simply, the P wave reflects all of the depolarizations that are formed in all of the atrial muscle cells. Q, R and S waves, or the QRS complex, is the reflection of all of the depolarizations in all of the ventricular muscle cells, and T wave is the reflection of all of the repolarization phases in all of the ventricular muscle cells. The third and the last point is that I have already mentioned that the heart is a three-dimensional organ and the action potential spreads in 3 dimensions. However, electrocardiography is only able to record 2 dimensions of this electrical activity. 2 dimensions means a plane. How many planes do we have in electrocardiography? It is 2. The frontal plane and the horizontal plane. You can easily imagine the frontal plane being parallel to the whiteboard. So when we are using the whiteboard, it's going to be easy. I am going to talk about the frontal plane in this video. But in the coming videos, we will be talking about the next plane, which is the horizontal plane. Unfortunately, I'm going to use the vertical whiteboard, but I will ask you to imagine the horizontal plane to be on your desktops, as I am going to talk about the horizontal plane in the coming videos. So let us start with the depolarization wave of the atrial muscle cells.